This is the lesson Is Matter Pure? In this chapter, we are going to learn what is physical change, chemical change, and the difference. What is pure substance and mixture? What are elements and compounds? And in mixtures, you have two types homogeneous mixtures and heterogeneous mixtures. And what is solution, suspension, and collide? And what is Tyndall effect? And mixtures can be separated in various techniques. And we're going to learn the separation techniques of the mixtures. To explain physical change, consider a beaker in which some sugar is taken and water is added to it. After stirring, you observe sugar butter. Sugar is completely dissolved in water. Here, the composition of substances, the sugar and water remains same, and no new substance is formed. Here, only change of state is occurred. Some other examples are water mixed with salt, breaking of glass, cutting wood, and melting ice, and many more are there. So what is chemical change? Chemical change is permanent change. For example, if you take a beaker and you collect some sugar on that and add hydrochloric acid to it, you will get a substance which is called sugar charcoal, which has the property different from its constituent substances. Its constituent substances are sugar and HCl. After reaction, sugar charcoal is formed. This sugar charcoal has completely different properties from their constituent substances. This type of change is called chemical change. Some other examples of chemical change are rusting, burning wood, and many more. Matter is further divided into pure substances and mixtures. The main difference between pure substance and mixture: pure substance is made up of only one kind of particles. For example, if you consider gold, the substance gold contains only gold particles. If you consider water, this contains only H2O particles. Consider iron. Pure iron contains only iron particles. Mixtures, these are made up of two or more other substances. Two or more pure substances. For example, soil. Soil is made up of sand, contains some clay, and also contains some moisture, and so on. Pure substances are mainly classified into two categories. One is element, other is compound. Element, this is a pure substance made up of one kind of atoms and cannot be broken up into two or more simpler substances. For example, gold. This is an element with symbol Au, and you can take iron and so on. Elements cannot be broken up two or more simpler substances by physical or chemical means. And this element contains atom. This atom of an element is the smallest unit and shows the properties of the element. Whatever the properties element have, the properties of the element will shown by atom. Some properties of elements are: these are homogeneous in nature and they have sharp boiling points and melting point. And these elements can be further divided into metals, non-metals, and metalloids. Metals, these are readily lose electron and becomes positive ion. For example, if you take sodium, sodium has one excess electron. To get the stability, that sodium loses its electron and becomes Na plus. And metals are all solids except mercury, which is liquid at room temperature. And metals have the property that they are luster, means they have shining property. They show sonority, means if you beat it with something like hammer, it gives some type of ring sound. And all the metals are malleable, means they can be hammered into thin sheets. And metals are ductile, means they can be made wires, and they are good thermal and electric conductors. Non-metals, in non-metals 11 are gases and one, that is bromine, is liquid, and all others are solids. Means non-metals can exist in three states of matter, and non-metals gains electron and becomes negative ions. For example, chlorine plus electron, here chlorine is non-metal. And you have metalloids, they have intermediate characters of metals and non-metal. Germanium, silicon, gallium, these are the examples for metalloids, and these can react with acids as well as bases. Non-metals will not show the properties shown by the metals, that is they won't show the property of sonority, malleability, ductility, and they are not good conductors of electricity and heat. Compound is also a pure substance. This is composed of two or more elements that are chemically bound with one another in fixed proportion. For example, you consider water is H2O. This is composed with hydrogen and oxygen in fixed proportion, means H2O contains two atoms of hydrogen and one atom of oxygen. Means water is just H2O, means this is a fixed proportion. Water will not be H3O4 or H2O5, not like this. And one more example is carbon dioxide, and other is ammonia. And sugar is C12H22O11. What it means is sugar compound contains 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Properties of compounds can be broken into its constituents elements. Means H2O can be broken up to hydrogen and oxygen by the method of electrolysis. And compounds have distinct set of properties, means they show different properties sometimes, and these properties are other than the properties of constant atoms. For example, NaCl NaCl is called table salt, and this is harmless. Its constants elements sodium and chlorine. Sodium is very reactive. When it in contact with water or moisture, it explodes. And chlorine is poisonous gas. And one more is they have sharp melting point and boiling points. For example, melting point of ice is 0 degrees Celsius, which is fixed, and boiling point of water is 100 degrees Celsius, which is fixed. Solution, suspension, and collide. To explain this, we need three beakers, and we have to fill the beakers up to the equal level. And in the first one, you have to add some sugar, and you have to stir it so that sugar will be mixed here. And in second, you have to take chalk powder. If chalk powder is mixed and you stir, then chalk powder will not be mixed in sugar and the particles will be suspended. The particles of chalk will be like this. In third beaker, if some milk is added and if you stir, the milk will be mixed. The first one is called solution, the second one is suspension, and the third one is collide. Here some properties of solution, suspension, and collide. Solution is homogeneous mixture, means it looks same. If you take any part in the solution, it gives the same physical properties as the whole, and the two, it is formed with two or more substituents. All the physical properties are same in any part of the solution, and particle size is 1 nanometer. 1 nanometer means 10 power minus 9 meters. So the particle size is less than 10 power minus 9 meters. That's why if you pass the light through the solution, and the path will not be visible because the particles of this size are not able to scatter the light. So the light is not visible in case of solution, and this solution cannot be separated with filter paper. If you use filter paper to filter this solution, then the sugar particles cannot be separated as the size is very less. If the solution is left undisturbed for some time, the sugar particles will not settle down. These are the main properties of solution. And if you go to suspension, suspension is heterogeneous mixture, because chalk powder is not mixed here. Solute particles can be seen because size of the solute particles is greater than 2000 angstroms. Angstrom is 10 power minus 10 meter. So 2000 angstroms, the size of the particle more than 2000 angstroms. That's why the solute particles can be seen, and the particles remain suspended. Particles will be suspended in the solution and can be separated with filter paper. If you keep this in a filter paper, then the chalk powder will be separated and the water is collected in the beaker. So we can separate the solute particles of suspension, and if left undisturbed for some time, then the particles here, the chalk powder will settle down at the bottom. If it is left undisturbed, the chalk powder will be collected here. And if you go to collide, the collide, here we took example of adding milk to the water. This is also heterogeneous mixture, but you feel that it is homogeneous. You feel the milk is distributed equally or uniformly throughout the solution, but it is not actually correct. If you observe the things in under electronic microscope, then the milk contains fat and other things. These will not be uniformly distributed. So, this is not homogeneous mixture, this is heterogeneous mixture, and the size of the particle is 10 angstrom to 2000 angstroms, and this cannot be separated by filter paper. If you keep your milk in filter paper, the milk particles will not be separated. So, the filter paper is not useful to separate the colloid. It contains dispersed phase and dispersed medium. Dispersed phase is formed by the particles, and dispersed medium is the component in which dispersed phase is there. If you focus light here, then the path is visible because the particles in the suspension are sufficient in size to scatter the light. That is why the path is visible in the liquid. Similarly, if you pass light through the colloid, the particles here also able to scatter the light. That is why the path of the light is also visible here. So, a beam of light is observed in suspensions and colloids. If you pass the light through them, means the light is scattered by the particles in suspension and colloid. The phenomena of scattering of light by the particles is called Tyndall effect. That is why Tyndall effect is observed in colloids, and Tyndall effect is also observed in some suspensions. Tyndall effect, this is the definition, the phenomena of scattering of light by the particles of colloids or in suspensions is called Tyndall effect. The examples are, you can observe the Tyndall effect in forest, because in forest there will be mist. Mist is nothing but it contains some tiny droplets. Due to these tiny droplets of water, the light is scattered and we observe Tyndall effect. In our daily life, when a fine beam of light enters a room which is somewhat dark, its small hole, Tyndall effect is observed. This is because the room contains some dust particles and also smoke. Due to these dust particles and smoke, the light will be scattered. Due to the scattering of light, Tyndall effect is observed in this condition also. Every solution will have two parts. One is solute and other is solvent. In sugar solution, you have sugar and water. In these two, the component of the solution present in smaller amount is called solute. Obviously, in sugar solution, sugar will be of smaller amount. So, sugar is solute and sugar is dissolved in water which is in larger amount. That is why water is called the solvent. In similar way, in salt solution, salt is solute and water is solvent. And one more definition I want to give you, that solubility. It can be defined as the maximum amount of solute that will dissolve in certain amount of solvent. The maximum, so beyond this limit we cannot and the solute will not be dissolved in solvent. This amount is called, this maximum amount is called solubility. We must give the information of temperature also. So, the definition will become as the maximum amount of solute that will dissolve in certain amount of solvent at given temperature. I am giving you one example. 36 grams of table salt, that is NaCl, can be dissolved in 100 grams of water at 20 degrees Celsius. So we can say the solubility of NaCl at 20 degrees Celsius. If the temperature is increased, it will not be 36. That's why temperature is must to note. So at 20 degrees Celsius, the solubility is 36 grams. Concentration of solution be calculated in two ways. One is mass by mass percentage of solution. This is the formula for that, mass of solute by mass of solution into 100%, and one more is mass by volume percent, which is mass of solute by volume of the solution into 100%. Here is one example. A solution contains 40 grams of NaCl in 220 grams of water. Calculate the weight percentage of solution. So for this, what is given, weight of solute is given. It is 40 grams, and also weight of solvent, this is 220 grams. So what will be the weight of solution? Weight of solution is sum of weight of solute and weight of solvent. So 40 plus 220, which is equals to 260 grams. So we have to apply the formula. Weight percentage is equals to weight of solute, which is 40 grams, by weight of solution, which is 260 grams, into 100%. So this 0 gets cancelled. So it is around 400 by 26. And if you calculate 26 ones are 14140, so it's around 5 15 point something, 15.3%. So in this way you can calculate the weight percentage, mass by mass percentage, mass by volume percent. Take a beaker and add some sugar in this and stir it well, so that the sugar can be mixed. This type of solution is called unsaturated solution. In unsaturated solution, you are able to add solute, means some more solute can be added. Now add add some more sugar here. Then that sugar also dissolved, and a certain limit reached. Beyond the limit, you are unable to add any solute particle. In that condition, the solution is called saturated solution. In this condition, no more solute can be added. If you add some more after reaching the saturation state, then it will be deposited in the solution like this. If you supply some heat, then these solute particles will be dissolved in the water. Due to the increase of temperature, these solute particles which are undissolved can be dissolved by the application of heat. This type of solution is called super saturated solution. Dissolves more than its solubility. If this supersaturated solution disturbed, then the excess amount of solute dissolved in the solution forms as precipitate, and the solution again becomes a saturated solution. Various techniques are there for the separation of mixtures. If in a mixture, if one of them is magnetic material, means it is attracted to magnet. For example, if you take sulfur powder plus iron filings. Then this can be separated. A simple technique. A magnet can be used, and these iron filings will be attracted to magnet, and sulfur remains. In this way, you can separate this type of things. And one more is, if you take sugar solution or salt solution, if you want to separate, then you have to heat it. After heating the solvent, water is vaporized, and salt remains. Evaporation is also a process to separate the mixtures. Filtration is other process in which insoluble solids are present. You can use the process filtration. By using filter paper, the filtration process can be done. Centrifugation. This process is used to separate the butter, cream, and other fatty materials from the milk. In the laboratory, to separate in blood tests, the centrifugation process is used. This sublimation process is used when one of the material in the mixture is sublimable material. For example, you have given sodium chloride and ammonium chloride, and you are asked to separate these two. Then this sublimation technique is used, and with these two, the mixture is collected in a dish. An apparatus should be kept like this, and using cotton, this is closed, and you have to heat it. As ammonium chloride is sublimable material, so there is no liquid state for this. Directly this will move as vapor, and after getting sufficient heat temperature, it moves up. If you cut off the heat, then the ammonium chloride will be formed like this in this funnel. Any sublimable material can be separated using this process. Chromatography. Chromatography is the process used to separate the mixture when the mixture comprises solutes that dissolve in the same solvent. For example, if you take a sketch pen, if you want to separate the colors, or if you want to separate the colors in ink drop, there will be number of colors. For this, you have to take a filter paper, and this filter paper should be marked with the sketch whose colors are to be separated, and this line should be drawn almost above 3 centimeters from the bottom of filter paper, and this should be kept in a beaker of water, and the water level, it will be down, means it should not touch this color. After some time, the water rises, and the colors will be formed like this. Means in this color, you have 4 colors, and these are formed on paper like this. The most soluble rises faster and higher. Here, color which is on the top is red. This is the most soluble color, and it rised high. And this process is also used to find the drugs in blood. This is separating funnel, which is used to separate immiscible liquids. Immiscible means the liquids which do not mix are called immiscible liquids. For example, if you take kerosene and water, due to the difference of their densities, these two will not mix together. They should be collected in a separating funnel, and there will be a stopcock. If we open this, then the liquid, the bottom liquid comes and collected in this beaker. So after settling like this, means if kerosene and water are separated like this, then you have to open the stopcock so that the liquid here comes down and it is collected in this beaker, and you have to be very careful. Close the stopcock after all the water collected in this beaker, so that only kerosene should remain in this separating funnel. In this way, immiscible liquids can be separated. If the liquids are miscible means they can be mixed together. For example, acetone and water. The boiling points of acetone and water is greater than 25 degrees Celsius. This distillation process is applicable only for the miscible liquids whose boiling point is more than 25 degrees Celsius. You have to collect the miscible liquids here, and this is the thermometer to read the temperature, and this is a condenser which cools the vapor. For this there will be inlet for cold water and there will be outlet, because this cold water cools the vapor, and the vapor is converted to liquid, and that liquid is collected here. Now the Bunsen burner makes the miscible liquid to heat. After getting the enough temperature, after reaching the boiling point, vapor moves up and it has this way to move, and it will move in this way. After reaching the condenser chamber, it will be cooled down. It will become liquid and collected in this chamber. The other liquid which is having higher boiling point will remain in this jar itself. This thermometer is used to stop the heating when required. This is fractional distillation. This is also used to separate miscible liquids, but the difference between distillation and fractional distillation is, in distillations the boiling point of liquids will be more than 25 degrees Celsius, and that distillation process is not applicable if the miscible liquids boiling point has a difference of less than 25 degrees Celsius. I am considering two liquids, N-hexane and N-heptane. These two are miscible and these two are collected here. And the difference between distillation and fractional distillation apparatus is only one thing. Here one fractionating column is appearing. This fractionating column contain glass beads. When the heat is supplied, as the boiling point of the liquids are less than 25, the two liquids will become vapors in little time interval, and they will move up and trapped in this glass beads, and the liquid whose boiling point is less compared to the other moves up and it follow this path and it enters the condenser chamber, in which it cools and it moves as liquid and it is collected in this. The pure liquid component will be collected here, and the other liquid which is having a slight greater boiling point, which is trapped in glass beads, will be cooled down and again it comes to this chamber in liquid form. In this way we can separate the miscible liquids whose boiling point difference is less than 25 degrees Celsius. This is the distillation chamber used to separate the air. The air is collected from here and it is cooled. From this some water and carbon dioxide is removed. After cooling, the air will be liquefied, and liquefied air is sent to the fractionating column. In this fractionating column, a heater will be there, and this will heat the air. And as the components of air like nitrogen, oxygen, etc., have different boiling points, the boiling point of nitrogen is minus 196 degrees Celsius, so it will be collected from the top, and argon from the middle, like this, as its boiling point is minus 186 degrees Celsius, and oxygen as its boiling point is minus 183 degrees Celsius, and krypton, xenon, these are collected from the bottom as their boiling point is minus 154 degrees Celsius. And from this you can separate oxygen also, and this oxygen will be cooled and collected in a chamber as liquid oxygen.